BRT is the University of Oklahoma's high-powered rocketry team. The team is comprised of graduating seniors completing their capstone project, as well as underclassmen learning the fundamentals of rocketry. This year, our team is competing in the 2021 Argonia Cup competition, where the goal is to launch a rocket to 8,000 feet, deploy some type of descent vehicle, and carry a golf ball payload safely down to a specified target on the ground.
The team solution was basically derived through a couple of phases. So we started in conceptual phase, where we thought of a lot of different ideas and kind of narrowed down to converting mission parameters based off the competition into precise design parameters. And that kind of narrowed down trade studies to be made about the diameter, what materials we want to use, what types of descent vehicles we want to use. And then from there, we ultimately concluded our design on a foldable quadcopter. Specifically, it would fold around the centroid like a pair of scissors and fit in a 4-inch diameter rocket.
So during the conceptual and preliminary design phases, we really looked at how we can best meet our altitude while carrying the payload that we have. So the main numbers we were worried with here were the stability of the rocket to make sure that it's stable and can actually remain on its trajectory as it ascends, as well as the apogee that we will reach.
The booster is configured with 4 fins made out of a Baltic birch and carbon ply composite. We decided with about 49 inches in length, and that just was a constraint based off of how much parachute volume we need versus where our actual motor casing ended. And speaking of the casing, we chose a L motor, specifically an L1420R, which is about a 80% L motor, almost maxing out what we're allowed with competition. And yeah, other than that, really the 4 fins is the main design choice on the booster subassembly, because we wanted to push our center of pressure far down as possible, but keeping in regard our distance between our center of gravity. We were just playing and optimizing our stability for our final launch vehicle. The avionics bay is constructed and designed with a redundant system in mind, so redundant batteries, switches, and altimeters. Our primary altimeter is also our GPS and telemetry tracker, the Telemetrum, and we have a backup Easy Mini. We plan to use a redundant feature in the software to where we fire charges at apogee and with 2-second delays, so there'll be 4 charges sequentially.
The biggest thing we had to figure out was how to size the descent vehicle. Pretty much from the beginning, we knew we wanted to use a quadcopter because it would be very controllable. We could land it exactly where we wanted, and the flight control software is already available commercially, so we're using Betaflight. We knew we needed to make the quadcopter fold into a small space. However, because rockets are long, we still could have the quadcopter be long in one dimension. So we came up with the folding idea based on a pair of scissors, which also simplifies things because really there's only one moving part. The core of the drone is the carbon fiber frame. There's 3 pieces, 2 of which are mostly identical, the 2 arms carrying the propellers. The 3rd piece is just a plate we use to mount the electronics that helps us route the wires where we need to, keep the components where we want them to be, and just spaces things out.
The propellers are 6-inch, 2-bladed. This allows us to better stow the quad in the rocket on ascent. There are a litany of tests that we completed to make sure that our solution will indeed work on game day. One of these tests is a range test. This is designed to address one of our 2 main concerns, being can we connect at maximum range? Given our aerodynamic calculations, the furthest we're ever going to be away from our ground station is about 2 miles or 11,000 feet. So the way that we address this is we find 2 places on the ground about 2 miles apart and see if the quad will connect. Yeah, I'm sorry, but can we start from the beginning again? I'll do a little
The
bit
beginning? Okay.
Well, I mean,
Just go ahead and delete the whole thing.
Actually, scratch everything. We're starting over tomorrow. Everyone be back here.
I can do that.
Repeat.
I do my own stunts too.